Hi, everybody. Welcome to Agoric's Pillar Series event for January. And we're happy to have everybody with us. And today we have our Chief Scientist and Co-founder, Mark Miller, here talking with founder and lead developer of MetaMask, Dan Finlay. So really excited to have them talking about security in Web3 and how Agoric's technology and MetaMask have been working to make sure that third-party packages are secure and we can effectively compartmentalize security in this new world. So I'm going to bring them both on now.
Hey, how's it going, Roland? Hey, Mark. Good to see you.
Yeah. So I'm Mark Miller. I'm Chief Scientist of Agoric, and I've been working on language-based security and smart contracting for many decades, actually, going back to 1988.
Yep, and I'm a big fan of you and your work, and we've been using it over at MetaMask and in an increasing amount over the last couple of years.
So really happy to have you guys both on. And just for context, I'm going to play a very light moderating role here. I'm a Roland product manager at Agoric, and I'll seed you guys with a few questions, but happy to just have you guys talk, and I'll pop in if we get any questions from the audience or if anything else comes in. So I guess just to start out with, and maybe I'll start with you, Mark, would love to have you talk about SES, what it is, how it provides sandboxing of third-party packages, and then how that sort of forms the basis for other things. And Dan, we'll let you just jump in after that.
So I'll do a very, very brief history of how we got to SES to give better orientation about what SES is. In the late 90s to early 2000s, I did a research language named E and formed an open source community around it, eWrites.org, where we did research on language-based expression of smart contracts and also just general purpose language-based security, and E was a distributed secure programming language. In 2007, I joined the EcmaScript committee representing Google, and got into JavaScript, got into standard JavaScript, the enablers that enable us to use JavaScript as a secure programming language, and in fact, as a distributed secure programming language, which Agoric is now doing. And what we mean by that is that JavaScript, as used normally, has the property that everything is fully vulnerable to everything else. That any package that you load, if it's malicious or even if it has an exploitable flaw such that it can be subverted, it can do arbitrary damage to anything else in the application that it's running in. There's complete vulnerability. What we introduced starting with EcmaScript 5 are primitives like object.freeze that enable us to run JavaScript packages under the principle of least authority. The principle of least authority is really the key security property to everything that we're talking about. That's the security property that a piece of code, a module, a package, a class, an object, a piece of code should be given the least authority, the least ability to cause effects in the world that it needs in order to do its proper job. And Roland, could you throw up that graphic, the graph? So it turns out, thank you. So it turns out that most code does not actually need much authority to do damage in order to do its proper legitimate job. But JavaScript gives it complete authority to damage everything. SES, the secure form of JavaScript, which can be run through the SES shim right now securely on existing JavaScript, as well as to be supported directly by the platform as the SES proposal makes it through the standards process, enables us to run individual packages with authority that we provide and prevent them from arbitrarily damaging others. So over here we have a graph of the packages that make up MetaMask with the import graph, the dependency graph between the packages. And if this was run in normal JavaScript, as it was before MetaMask adopted our technology, you would color each of these dots red, meaning that you're completely at risk to everything. As run under least authority, using the Agoric SES technology and the MetaMask lava mode technology, this graph, by the way, was generated from the MetaMask lava mode technology. We color these things according to the authority, the dangerous authority that they're provided. And as we see, most of them are colored green, meaning we actually needed to provide them little authority. And what that hopefully means, as run under this framework, is that if they have a subvertible flaw, their ability to cause damage to the rest of the system is less risky, not zero risk, but less risky than the others. The ones that are still colored red are the ones that, in order to do their legitimate job, still need tremendous authority. So even run under the principle of least authority, you're still in a lot of danger to them. Now, the purple node in the middle is interesting. NPM estimates that the typical JavaScript application consists 97% of third-party modules loaded and linked in, and only 3% of code custom written to that application. The purple node, as I understand it, is MetaMask itself in terms of the code that was custom written to be MetaMask, and the others are the third-party modules that MetaMask draws in. This is typical. This is anything built for the web these days will have a graph like this. And being able to narrow your review process, narrow your chief worries only to the remaining red nodes on that graph is a very, very big deal.
Yep, that's a good summary. I guess I could jump in and talk a little bit about how we at MetaMask got here and discovered Agoric's work. So I'm not sure how many of the viewers are familiar with MetaMask. So a super high level is MetaMask is a cryptocurrency wallet originally built and currently solely supporting the Ethereum blockchain. The Ethereum blockchain was different from the previous blockchains in that it had a whole computer on it. And so it was able to do anything. So when we were thinking of making an Ethereum wallet, we were saying this isn't just good for sending and receiving the base currency Ether. People need to be able to interact with arbitrary code. So we were thinking, oh, people could make new kinds of voting systems and they could auction things and they could mint new currencies on the platform. And we were like, this has to be really open-ended. So we need a wallet that can let people do anything. Now people aren't going to be crafting every single interaction themselves. Usually there's going to be someone who writes a smart contract and inviting users to interact with it. And so what we needed to do is we needed to make a wallet that's able to interact with some code that's basically untrusted in a safe way. And really that's, I think, sets the tone for that. Once you're writing code where you're writing code that needs to interact with something it doesn't trust, you're kind of on track to discover a lot of Agoric's work, because that's the scenario that they've been planning for a long time. And so our first kind of innovation in this field was requiring transaction confirmations. So we made a browser extension, and users can go to a website, and we chose browser extensions and websites because it is probably the most safely confined way to visit some untrusted code that the average computer has today. It's not perfect, but you can load a web page and it's not wreaking complete havoc on your computer. And that web page can now suggest things to you, like, would you like to buy this new token? And rather than simply having access to your keys, we then get a little pop-up and the user gets the ability to approve or reject. And as we were building this, after a couple of years, we started realizing users wanted to approve more and more things. They wanted to approve allowances. They wanted to enable new kinds of contract interactions. The blockchain applications were getting so sophisticated, they were essentially becoming new protocols. Our confirmations were getting less and less useful. They're essentially becoming, do you want to do something? and we needed a way to expand what we were doing internally more rapidly. And meanwhile, we had more pressure to expand and add features than ever, but simultaneously the risk of introducing a vulnerable dependency was higher than ever. Every time we merge a pull request, and people, they like writing pull requests for their favorite wallet. We've got a very enthusiastic fan base, and we're very grateful for it. But every pull request, it's a new liability, and like that graph that Mark showed, we have a lot of dependencies that we have, and we pull in, and each one of those in a normal JavaScript application has the ability to kind of do anything. And that's kind of the broken thing about modern JavaScript. And I think it's actually so bad that JavaScript has a reputation for just being insecure. And a lot of times when I start talking about this stuff, as soon as I say JavaScript, people check out. They actually just assume JavaScript is bad. And yet we browse the web. We have multiple tabs. They are confined. We know there's some kind of way to confine code. And what Agoric has done is they've created a framework for introducing a degree of confinement at the language level. And we don't have to assume that the confinement is perfect to say that it is definitely improving safety. So in that graph that Mark showed, we have a lot of modules, and formerly all of them could trivially alter the wallet code in any way. And that kind of supply chain attack has formerly successfully hacked Bitcoin wallets implemented in JavaScript. And there was a kind of viral tweet last week that suggested that React Native, basically JavaScript applications, because of their supply chains, could never be trusted to hold cryptocurrency funds. But really, this kind of supply chain vulnerability applies to any language. Like, it's not like other languages are magically handling confinement well. So the notion that languages should make strong confinement easy, and not just easy, because like you can have, there's like secure distributions of Linux that are very hard to configure. It shouldn't just be easy. It should be as natural as using the language itself. And that's really what Agoric's work is they're saying, if you just take off the kind of ambient authority in JavaScript, no longer able to just casually access the disk, casually access the network, but instead, basically in the spirit of maybe kind of like functional programming, but also objects oriented, you only get access to the things you're explicitly passed. Frankly, it's a lot easier to reason about as a developer. You don't have to wonder, like, are there implications from bringing in this dependency? You simply say, hey, did I give it to the dependency? No, I never gave it. I never passed it the network module. So anyways, once we've been working on this, the ways that we encountered it, it was so multifaceted because we're doing it. We are interacting with untrusted code, but then we also are importing untrusted code. We're letting users interact with websites, and yet we want to add features. So we really had this trifold, trilemma of we want to add more features, we want to get more secure, we want to enable users to take secure risks. And we basically found all three of these fronts were facilitated by working with Agoric and integrating their technology. So the one that Mark was really highlighting there is our LavaMoat project, which is a build tool that the design goal is it can work for any modern JavaScript project today. So we've got it working today with Webpack and Browserify. Actually, there's many versions of Webpack, so it's going to take a little long to cover all of them. But the core is portable, so any build system should be able to bring in LavaMoat and now add these secure EcmaScript or SES confinements around every single dependency. And we were able to automatically generate a configuration file that confines them. So LavaMoat itself doesn't have the full object capability realization. If you had proper SES, all of your dependencies would stop assuming they had global access to fetch or to settle crypto or to your disk. The require statement itself is a form of vulnerability for JavaScript developers, but in order to support backwards compatibility, we've added this kind of configuration layer, and we're able to automatically generate it. And basically, for every dependency, you just say we're able to tell you, hey, this wants disk. Or this wants network, and you might say, hey, I just wanted that to color some text. Why does it want network and disk? Like, that's suspicious. And we're able to give you a config file that basically represents the most security critical details of your application. And if we just shut off all the authority, like in that graph that Mark showed, we're able to say, okay, all those green modules are now confined so tightly that actually we can be less afraid of them. And now we can focus our audit energy on those red modules. Now, the purple module, of course, is our code. It's the most well audited of all of our code. But those red modules, those are the ones to focus on. We're not saying the confinement is perfect. We're not saying we don't need to audit other things, but we have better confinement, and we now can focus our auditability. It can be really scary when you can't trust anything. So that's a little bit on our lava moat. But and then I don't want to go too deep off the deep end, because this is only a 30-minute call, but just to hint at the rest of this universe is that not only are we finding that this is useful for our own internal development, but we started realizing that actually if we can construct our own application in a way where new additions are also confined using this pattern, then we can be a little bit more casual about the integration of those features. And essentially, and our goal is now to allow even inviting the wider community to choose the features that come in. Of course, every feature you integrate gets some amount of authority to do its job. But given a code review of it, a static linking to that package, and limited authority, we have a pattern where a much broader number of people can start integrating features into their code, into their wallet, much faster than ever before. And I really see it as a total game changer for how software works. It's just the tip of the iceberg. I really think that in a few years, I think if people understand the implications, it will change how software is built. More applications will be more socially inviting, more casual to extend, more safe to extend, and I think we'll have an explosion of safe innovation, and I think it'll get very interesting very fast.
So and Dan, I think you're kind of already getting at the question I'm about to ask. But I think externally, a lot of people look at security as an unsexy thing, and at Agoric, we kind of don't think about it that way. We see security as an enabler, and I'd love to ask Mark for the types of interactions that Dan is talking about. What does it mean to be able to have this kind of security in your contracts as well? And what does that do for sort of the growth of the ecosystem itself?
Yeah, so what Agoric is building is we're building a smart contracting system in SES, and we're building a blockchain, and we're running SES on the blockchain, and we're running our smart contracts on SES running on the blockchain. Where Agoric is also participating in IBC, the inter-blockchain protocol, that enables blockchains to talk to each other, including mutually suspicious blockchains, enables blockchains to talk to non-blockchains. And on that, we're running our distributed object protocol. So we're actually running distributed SES across platforms, all the way to SES running in the wallet, running in MetaMask, speaking distributed objects, to SES objects running on the blockchain. So it's the whole fabric. It can now be reconceived as objects with secure references to other objects sending secure messages. And the way in which we're building smart contracts, as a result, by building it in this object capability model, the result is more easily understood, more easy for a developer or contract author to look at it and get confidence that their contract means what they think it means, and especially it's more easy to break it down into composable pieces that can be reviewed separately, in which, as consistent with the graph you were just looking at, in which the risk can be partitioned among those pieces, so that when you're reviewing each piece, you can review it with regard to the risks that remain only for that piece. And then we can build the contracts by composing such pieces together, composing separately vetted pieces together. The key there is Zoe, our smart contracting framework, that takes care of a major part of the contracting risk, which is we're no longer giving each individual contract, the separate code of each individual contract, direct access to the assets at stake. Instead, users make offers through Zoe to the contract. The offer says, I want this for that. And Zoe guarantees that even if the contract misbehaves, the user gets back either what they wanted or they get a refund of all the rights they put up into escrow. The contract, even if it misbehaves, can't violate that. There's still other security issues that are vulnerable to the contract, but now we've partitioned risk so we can look at the risk separately, bringing very much the principles to the writing of contracts in a modular fashion that is consistent with the principles that Dan and I were just talking about on the front end in the code that runs in the browser, how we partition risk there.
And we had a couple questions come in. So I wanted to ask the most recent one, which is a question about SES. Is it theoretically possible to lock down the initial scope? Could we get to the point where devs just need to drop in SES without compartmentalizing all dependencies?
There has to be some code that is SES aware, that sets the system up, and that expresses policy choices. If you just drop SES into a browser, you just turn on the SES switch, but you don't do anything more, then you really haven't accomplished anything. However, the code that needs to be SES aware can be a tiny fraction of the overall system if the static analysis of the rest of the system, as shown on the graph, determines that most of those modules are green, and then the tools that Agoric and MetaMask together have built will then enable those things to be configured such that the risk to each of those individual modules is reduced. So the burden is much smaller than you expect, but it is certainly not zero.
Great. And Dan, I'd love to also give you a chance to talk about, you mentioned the state of your code and auditing the code prior to lava mode, and now you've implemented it and you can sort of view things in the same way the image that Mark had looks. Curious what that enables for you, where you see MetaMask going with this technology, and what you're excited about coming up.
Yeah, so we are. I'd say we're incrementally implementing what we've shown there. So we've implemented a few degrees of it, and there are more degrees of it that we can implement. So the full ultimate confinement of all of our applications and all of their build systems there's obviously a long way that can always improve. But I think of it partly as an insurance policy. You know, when we are merging in a new code, we can be a little bit less afraid of new dependencies for that reason. But how it enables us going forward is it enables, let's say, we say we've got a new feature that we want a new team to take care of. Now, a lot of the burden of maintaining a very popular application is merging together all the work. Today, formerly we've had to very, very rigorously audit each new contribution. If we're able to say, okay, this new team, they're in charge of this view, and let's say a portfolio view, and all it needs to render is some information about your assets, but it doesn't need any authority to act on those assets. We have a different team that's in charge of the actual swapping of assets. It's very, very easy to reason about the confinement of a portfolio view. They need probably access to the network or some kind of price feed, and then they need access to your account balances. But that's just like information. That's like read-only data. So they shouldn't need to write to your disk. They shouldn't need to access any other information. And so for how our team moves going forwards, I think that this is a framework for us to add entire new teams, both internally and externally, that are granted certain degrees of autonomy where we don't have to as closely review every single thing that they do, because, auditing code is hard work. And at a certain point, a code base is bigger than any one team can audit, right? Like, you may have one person who audits this part of code, but it may have implications for this part of code. So you end up needing somebody who has the whole project in their head. And And so the challenge for a rapidly changing product is how can we keep the product small enough that anyone can keep it in their head? And so I think it's funny because this principle, it applies at different layers of the stack. The challenge is, how do we keep the components simple enough that you can reason about them? And we're talking about that at the human level. We're talking about that at the code level. We're talking about it at the distributed system level. And as Mark was saying, we started by talking about dependencies, but these are kind of synchronously available in the same process. But then he started also talking about how Agoric is also working on a distributed object graph enabled by their CapTP technology and their blockchain and other kind of growing parts of that stack. So this is also an increasing way of having services that also interact. If we can have really, really clean networking between these processes, it can feel like JavaScript. And so I think that this also, from a developer experience perspective, also gives us a framework for allowing more ergonomic interfaces to secure interactions between each other. Today, the interface that we give to every web page is this thing called the Ethereum provider. It exposes basically a JSON RPC API, which was at the time the Ethereum community's best sense of how to keep an arm's length interface exposed. But it's not native to the language. You call an Ethereum function just to put in a string of JSON code that represents your function. But you're in a programming environment. Why aren't we just calling a function? And so there's a whole ecosystem of JavaScript abstractions written around this just to then reclaim the language level convenience. So if when the Agoric tools are assembled the way they intend, it feels like JavaScript and it feels familiar and comfortable and ergonomic. And so it also leads to developer happiness as well as core security and easier kind of automating collaboration through well-defined interfaces.
Yeah, two slogans that I think really bring some of these lessons together. Security is just extreme modularity. Now, take that with a grain of salt. That's a first approximation, but it's a very good first approximation. Modularity is all about avoiding needless dependencies between modules. So to the maximum extent, the modules can evolve separately without needing to coordinate their changes with each other. Vulnerability is a form of dependency. So reducing unneeded vulnerability between the modules does reduce unneeded dependence between modules. And what we have found in the committee, the way we've been able to sell all of these security enablers over the years, over 13 years now, to the committee to make JavaScript enabling of object capability security, is selling them all as enhancements to modularity, because the same mechanisms do both. The other slogan I want to introduce is, don't add security, remove insecurity. That most of the things that enable security in JavaScript are things like object.freeze that turns misfeatures off. So in particular, SES freezes all of the initial shared objects like object.prototype, array.prototype, etc. It's already well-recognized bad practice for a library to mutate those. Object.freeze prevents them from being mutated. And when you remove everything that enables bad practice, what you're left with is a language that's still fully capable of good practice, but in which preventing the bad practice has also prevented various kinds of attack. And experience at Google, at MetaMask, at Agoric, at Salesforce, and at Node has shown that a tremendous amount of existing JavaScript code runs compatibly under SES, runs compatibly under these restrictions, because most of what's taken away was already recognized as bad practice.
Great. Well, I know this was too short a conversation. We're already at time. So I want to give you guys both a chance to just say one last word, but really appreciate having you on, Dan, and Mark. I'm always grateful for your time here. So I'm gonna leave it to you. But for everyone watching, this is the Pillar series at Agoric. We do a call once a month. And please do come join our Discord if you want to continue the conversation. I'll drop a link in right now.
All right. Well, for my last word, yeah, I'll kind of just rehash a point that was there because you asked Roland a little bit about is security boring or something, but I really think that if you want to make a fun system, and that's really what we want to do, like fun is kind of the goal. I know cryptocurrency security, it's high stakes, but it should be fun. And to achieve a level of fun, you need to achieve a level of uninterruptedness and safety. You know, like if you want to play, you have to have a safe environment to do it in. And if you can just get that safety down really well up front, I think that we're going to build a computing substrate that is much more enjoyable and in turn increasingly a society. I even hope that is much more enjoyable to be a part of.
Yeah, and I think that with regard to making a society that's much more secure, is right now our civilization, our society rests on our computer infrastructure, and the degree of insecurity of that computer infrastructure is really terrible. It's terrible to an extent that I think it really does endanger our civilization. And all of these different steps to move towards secure software helps tremendously. And I think one thing about the blockchain ecosystem in particular, and by blockchain ecosystem, I include things like MetaMask that don't run on the blockchain, but are all motivated by blockchain to interact with blockchain, is that things have to be very secure in order to interact with blockchain. When people deploy exploitable stuff on blockchain, it gets exploited very quickly. Hundreds of millions of dollars disappear overnight with no recourse. And that means that insecure software that a company like Google would deploy and then manage the insecurity of for years, instead it dies in days after it gets deployed. And now we have an ecosystem populated by the survivors of that selection pressure, which gives us for the first chance a forum in which we have a chance of building an entire secure stack of software from the foundations to the user that have sufficiently hostile selective pressure that we can build something that is worthy of having our civilization rest on it.
Great. Well, I will end there. Again, thank you both for your time, and I'm going to pull you down now. And to everyone that joined, appreciate you coming and taking part in our Pillar series. I dropped a link to join us in Discord in the comments, so please do come talk to us if you're interested and want to learn more about either how the technology works or Agoric as a blockchain itself. And we look forward to more of these and continuing to grow our community through 2021. Thanks very much.